Welcome class. Today we're going to be covering chapter 3. The four main topics we're going to cover in this course will be Sketcher, part design, assembly, and finally drafting. So the first few weeks we'll spend it on Sketcher, then we'll move on to part design, where we create pads, extrudes, holes, pockets, etc. And once we get to assembly, we'll be combining the parts to create a product or an assembly similar to putting a bicycle together. And the last few weeks we'll be creating drawings of our parts and our assemblies. Alright, so chapter 3 lecture, Introduction to CATIA, CAT 31, Sketcher module or workbench. Alright, so anytime you open CATIA, first of all, be patient. Be patient when you first open CATIA. It may take a few minutes. It's a very powerful software. It eats up a lot of memory, so it does take a while to load CATIA. And one thing I want you to be aware of from the beginning is what module or workbench you are in. So here we're currently in the product structure workbench, which most likely you will never use or hardly ever use. I rarely use this workbench. So always be aware of which workbench you are currently in. So when you open up CATIA, always look to the upper right corner. So the workbenches we are going to be focusing on in this course are the following: part design. So part design is a single gear. Assembly, when you're placing parts together, like assembling a bicycle. Assembly design has the double gears. Okay, so assembly design, double gears. Drafting, so when we create drawings, we will be in the drafting workbench. As you can see, there's a little drafting workbench and a single gear on top. We are not going to be covering generative shape design. That's covered in CAD 37, the more advanced CATIA class. Generative shape design is for creating surfaces, wireframe, points, splines out in space in 3D. This is what's typically used in creating surfaces for a fuselage on an aircraft or wings. Or for automotive, generative shape design is used for creating the Class A surfaces, which are the surfaces for the interior or the surfaces representing the exterior of the vehicle. So we will not cover this workbench in this course. And I'm going to come back on using the shortcuts on the mouse for rotating, panning, and zooming in and out on the part. I'll come back to this slide. Alright, so always be aware of which workbench you are in. When you're creating a part, or when you want to create a part, you want to go into part design. Go into part design, and it'll show you the single gear, letting you know you are in the part design workbench or module. When you're ready to create a profile, you're going to go into Sketcher. Okay, so this is the icon for Sketcher. Look for the pen and the sheet of paper that you're creating a profile, a sketch. Once you click on the sketch command and pick a plane, so you can pick a plane to sketch on or a flat surface on a solid, it will take you into the Sketcher workbench. The icon's a little different, right? So from here, Sketcher looks like a sheet of paper and a pen. Once you're in it, the icon's a little different, as you can see, but this lets you know you are in Sketcher. And to exit the Sketcher, all you have to do is click on the yellow arrow to exit, and it'll take you back to the part design workbench. Alright, let's go ahead and go on to CATIA, and we'll come back and continue the lecture. The lecture notes. All right, so once you open CATIA, again, be patient. Don't keep double clicking on the CATIA icon, or you may end up opening a lot of CATIA sessions. It may really slow down your computer and or maybe even freeze or crash your computer. You have to restart. All right, so we're in the wrong workbench. So I'm going to just go ahead and close this file. And I'm going to go into the part design workbench. So I'm going to go to start, go down to mechanical design, and we're going to go into part design. We are going to be creating sketches, which eventually will turn into solids in part design. Okay, so let's go into part design. Here you can name your part if you like. I'll just leave it as the default part 1 and hit OK. All right, as you can see on the upper right corner, we are in part design. The part design workbench. Here is the sketch command to go into the sketch workbench. Okay, so once you open CATIA, go ahead and maximize. So I'm going to maximize this window. You can either double click on the frame on top or just go to maximize. It'll fill up the CATIA session. Let's fill up the computer screen or computer monitor by also maximizing CATIA. You can always minimize if you want. Come back to CATIA, maximize. All right, so we are in CATIA, and anytime you sketch, you want to sketch on a plane or a flat solid surface. We currently don't have any solids, so we're going to sketch on a plane. So I'm going to sketch, and I'm going to pick I'll pick this vertical plane, which is the YZ plane. See how it lights up in orange? Anytime you select something, it turns orange. So I'm going to click on the YZ plane. You can pick whichever plane you like when you're sketching. So notice now I am in the Sketcher workbench. Okay, so Sketcher workbench. And you'll see the grid in the background. Let me go ahead and exit the sketch. If I exit the sketch, it's not going to create. If I exit before creating any lines, it'll just avoid creating a sketch on the tree or a history. Since we didn't create a single element, it didn't even bother creating our first sketch in the tree. And our tree, a CATIA tree, is basically, think of it as a family history. It shows the history, the grandparents, the parents, children, grandchildren, etc. So it shows you a history of how the part was made. And I'll keep emphasizing the importance of creating parent geometry and children geometry, also referred to as the dependents. Without the parents, the children cannot exist, and so on. So I'll keep coming back to that, to the CATIA tree, and showing you the history. All right, so let's go back to the notes. Anytime you create a sketch, CATIA will automatically generate constraints. So these are constraints. Anytime you see an H, it's a horizontal constraint. So this line, obviously, is horizontal, and we cannot change the angle unless we delete the constraint. And V is the vertical. Okay, so V, we have vertical constraints. So these lines will always stay vertical. This line will stay horizontal. Okay, so H is for horizontal, V for vertical. Anytime you see a ring that's coincident, a ring with that's filled up is concentricity. That means the center point is shared by two circles, or a circle and an arc, or an arc and an arc. Fixed, when you anchor an element, it anchors it in location with respect to the origin of the sketch, and I'll demonstrate all of these in a few minutes. And we have perpendicularity, right? So if you want two lines to be perpendicular, 90 degrees to each other, you can add a perpendicularity constraint, 90 degrees. We have parallel. So these two lines, the relationship between them is parallelism. You'll see the double lines for parallelism. Then we also have tangency. So tangent, here we have an arc tangent to the vertical line, and we also have the arc tangent to this line. Okay, so this maintains tangency between the arc and the line. Double lines for tangency. Here's another example of constraints. Okay, so you can constrain by using dimensional constraints. You can use angles. Once again, anytime you see a ring, that tells you that there's a coincidence. A coincidence can be between a line and an axis, a point and a line. So I'll demonstrate all these constraints. So let's talk about sketch tools. This is very important. Sketch tools. Anytime you are in the Sketcher workbench, you're going to see this tool, the sketch tools. And these are on. So the default is to have these on. Anytime you see orange, it's on. When it's blue, it's off. Okay, so when you see orange, it's active. So the grid in the background is on. Snap. So this will snap as you're creating geometry. It'll snap to any intersection point on the grid. This one will automatically create relationships between geometry that you create, whether it's perpendicularity, horizontal, vertical, parallelism, etc. And this will create dimensional constraints. So it'll put a measurement or an angle as you're creating geometry. You want these on. Okay, so always keep these on. You have the option to turn them off. Just click on them and they will turn blue, but you want them on. One that I am going to turn off is snap. So I prefer to have snap turned off. I don't want my geometry that I'm creating to be snapping to the grid. Some of you will prefer the snap. So you can have that on. I prefer it off. Some will like the grid in the background. About half of you will prefer to have the grid in the background. The other half will not. It's just a matter of preference. I prefer to have the grid on. All right, so let's go back to CATIA. So when I create a sketch, it's going to automatically start populating the tree. So when I create a sketch, notice I clicked on sketch, it's orange, it's active. And if you don't know what to do next, just read here on the bottom left corner. It'll tell you what to do. It's asking you to select a plane or a planar surface on a solid. I'm going to pick the YZ plane. It's this vertical plane, as you can see. Okay, now we are in Sketcher, right? We are in the Sketcher module or workbench. If I hit the plus on the tree, notice we have a sketch. So this should be sketch 1, but remember earlier we first started creating a sketch. That would have been sketch 1, but I exited without creating geometry. So the next option or the next default name is sketch 2. Don't worry about the name. We can always change it if we like. We can always right click properties and change the name. Hit the plus. Let's see what's in here. So in our sketch, we have a vertical axis and a horizontal axis. Instead of an XY, CATIA uses for the sketch axes, it uses a vertical axis and a horizontal axis. And then we have the origin, right, at 0, 0, 0. So this is 0, 0, 0. All right, so let's create simple geometry. I'm just going to create the L shape in our lecture notes. So I'm going to go back and create this L shape. All right, so I'm going to simply use profile. Okay, so look for profile. Actually, let me move this toolbar over to the side here. There we go. Okay, so we have profile. And notice these are turned on, right? These are turned on. Notice my grid in the background is on. I have snap turned off. It's blue, so it's off. If I click on it, no, I'm going to go ahead and leave it on to show you the difference. So I'm going to create that L shape. So I'm going to go to Profile. Pretty sure you can see it. It's snapping to the grid, right? As you can see, it's snapping to the grid. And I'm going to pick the origin. Notice anytime you pick a point or an endpoint on a line, notice that filled blue circle. It lets you know you're picking a point or an endpoint of a line or a curve. So I'm going to click. Notice how it's snapping. Some of you are going to like that it snaps. When you see blue, that means it's either vertical or horizontal. So I got them mixed up. It's going to be horizontal or vertical, right? Anytime you see blue. Okay, I'm going to turn off this snapping option. So you can see now it's not snapping anymore. Notice the icon is blue. And as I'm creating geometry, notice how this sketch toolbar is extended to give me my horizontal and vertical coordinates. As I'm moving, it's giving me a horizontal. So horizontal, vertical coordinate, and it's giving me a length and an angle. As I'm moving, you can see my coordinates change. Here's my horizontal, my vertical, the length, and my angle that I'm currently at. Okay, so I'm just going to guesstimate a length. I'm going to click. Notice I created I know it's hard to see, but I created a horizontal constraint for my first element. And I also want you to notice that it's populating the tree. Hey, you created a line. And you need 2 points to define a line, so that's why we have 2 points to define our line. And it also created this constraint. This is the horizontal constraint. I'll come back to this. It's calling it parallelism. It's actually parallel to the horizontal axis. I'll come back and explain all this stuff. Okay, so I'm going to go vertical now. Notice it keeps creating more constraints. So it's automatically generating constraints, and it's also keeping a history of the geometry we're creating. So I'm just going to eyeball it. There it is. So it exited the profile command because I closed the profile. So it automatically exited on its own. All right. Notice it's orange. It's selected. So anytime you exit a command after you created geometry, it keeps it orange. It keeps it selected. To deselect, you can click out in space or hit the escape button, the upper key on the keyboard to escape. Or just click out in space and it deselects. Okay. All right. So let's talk about pan. What I did now is I held the wheel. I'm panning. As you can see, I'm holding onto the wheel and moving the mouse. So how was I able to do that? Let's go back to our, I think it was the second slide or third slide. Okay. To pan, you hold the wheel and move the mouse. To zoom in and out, you hold the wheel and tap the right button. You're going to hold onto the wheel and move the mouse up and down to zoom in and out. So we hold the wheel, tap the right button. So you tap it, you let go of the right button, but hold the wheel and then move the mouse up and down to zoom in and out. So let's practice. Okay, so to pan, hold the wheel, move the mouse. That allows us to pan. Now I'm holding onto the wheel and I'm going to tap the right button. I'm just going to tap it and I'm only going to hold on to the wheel. So I tap the right button. Now I move the mouse up and down. And I can zoom. Another option to zoom is the magnifying glass. You can zoom in using the plus magnifying glass. If you use the negative, it'll zoom out. And if I click on the yellow icon, this will do a fit all. It'll zoom fit everything into the screen. There it is. Again, you can zoom in. Sometimes you'll lose your place and don't know where you are with respect to the origin, and you can't find your geometry. Just do a zoom fit. And there it is. All right, so I want you to notice that it created a history of all your lines and points. Notice we created 1, 2, 3, 4, 5, 6 lines. That's why we have 6 lines. And all the endpoints are included. Now let's look at our constraints. So here we have this parallelism. So it's horizontal, but actually CATIA sees it as parallel to the horizontal axis. So instead of giving us a horizontal constraint, it's calling it parallelism, meaning this line is parallel to the horizontal axis. Okay, same thing with, let's look at V here. So here's V, vertical. It's not calling it vertical, it's calling it parallelism, number 2. So it's parallel to the vertical axis. So when I click on the V, it's letting us know that it's vertical or parallel to the vertical axis. Okay, and so on. So we have all these horizontals and verticals. And coincident, see this coincident? So when we created this endpoint, when we created this line, the endpoint stayed coincident to the vertical. So it locked it in place. All right, so when we're creating sketches, we want to see green. So currently these are white. So what's the difference? The difference is that a green object has been defined, it's been locked. So if I try to left mouse click and hold and drag this up and down, notice it's not letting me move it vertically. It's locked in place. But this one, if I left mouse click and hold, I can drag it. So this one hasn't been locked in place with respect to the origin or our axis system. Okay, so that's telling us, hey, we need a horizontal. Okay, so we need a horizontal dimension. So how do we add dimensions? Here we have the dimensional constraint, and this will add relationship constraints. So let's go back to the lecture notes. Some of this stuff I'm skipping, I'll come back to them later or in a later lecture. Okay, so this is the constraints toolbar. If you want to add a dimension or an angle, you use the second option, dimensional constraint. If you want to add geometric constraints, in other words, you want to add a relationship between existing geometry. So if you want to add perpendicularity, parallelism between two lines, or you want to add coincidence, you first pre-select the geometry, click on this first icon, and then it'll give you an option of what relationships are allowed to add to those pair or more pieces of geometry. Okay, so let's go ahead and play with these constraints. The constraints command. Okay, so I'm going to add a dimensional constraint. So I'm going to add a dimension between this line and this line. Doesn't matter what number, I just want to show you that it locks it in place. So now this is no longer allowed to move horizontally because we have a horizontal dimension. You can always change it by double clicking and changing the number. I'll just leave it at 80. And there it is, it's locked in place. You can always delete a constraint from the tree. Notice here's our dimensional constraint. Calls it an offset for our dimensional constraint. You can always right click delete if you like. You can always select it and hit the delete button on the keyboard if you ever need to delete a constraint. Okay, now this one is free to move vertically, so we need a vertical constraint. Okay, so now let me click in space to deselect. Notice it's orange. I'm going to create a dimensional constraint. Click, click, and there we have it. Okay, now if you're going to use the command over and over again, you can always double click on the command and it'll keep going until you hit escape on the keyboard or turn off the command. Okay, so I'm going to double click on this dimensional constraint. Double click. So now I'm going to add a dimension between this one and this one to lock this one horizontally. Notice it stays orange, it's still active, so I can now add another constraint and I can keep going. Okay, so once I'm done using a command, I can either deselect it and it'll go back to a bluish color, or hit escape on the keyboard to end the command or to exit the command. Sometimes you're in the middle of something, you don't realize you're in the middle of a command and it's driving you crazy because you're trying to do something else and CATIA won't allow you. Just hit escape. If you get stuck and you don't know what's going on, hit escape on the keyboard. So I typically keep a finger on the escape key all the time. I'm always hitting escape even when I don't need to, but you'll get into the habit of constantly hitting the escape key on the keyboard. Okay, so notice everything's green, everything's constrained. So we're good. Okay, and that's what we want. We want to see green on our sketches. All right, let's go back to the lecture. Actually, let's go ahead and practice relationship constraints or geometric constraints. Okay, I'm going to zoom in. I'm going to hold the wheel and tap the right button and move the mouse up and down. Let's say for some reason I wanted to add a hole. Notice it's trying to constrain itself to the midpoint, which, by the way, we can. So anytime you see a filled circle, it's either an endpoint and also a midpoint. You can always right click if you want to lock it at the midpoint. So if I wanted to lock the center of the hole to the midpoint, I can select here, right? If I wanted to. Now, one thing we're not allowed to is to have profiles. So these are two separate profiles. We have the green profile and the white circle. We cannot cross profiles. You actually can, but I don't advise it. Because once you exit the sketch, it'll be difficult to create a solid. Unless you know what you're doing, you have to do some extra moves. So I'm going to go ahead and delete this circle. Okay, so I'm going to delete the circle. I want you to notice that it kept the point of the circle. It's like a ghost point. It may cause you problems later on, it may not, but I'm going to go ahead and see the point. It's hard to see, it's orange. I'm going to go ahead and delete it. All right. If you ever make a mistake, you can always go to undo. This is the undo command. Undo, or you can always hit Control Z as shown to undo. Click on the arrow pointing left, or hit Control Z on the keyboard to go back. So if I wanted to bring back that point and the circle, I can hit Control Z. See, and it brought it back. Either hit Control Z or hit the arrow pointing to the left. All right, so once again, I'm going to delete this circle, delete it, right click, delete, and I don't need that point either. We can leave it alone. It's not going to cause any problems. It may, but I'm going to go ahead and delete it just to be safe. Okay, so I'm going to create a circle. And see, I can track the midpoint if I want. If I wanted the circle to line up with that midpoint, I can hover over this midpoint and just track away. See, now I was trying to grab this midpoint. See the light blue lines? That means it's tracking. Okay, so I'm going to just randomly pick a spot, but keep it centered to that midpoint. All right, so even though it tracked it, it didn't lock it. It didn't create a relationship. We can create a relationship if we want. But what I want to do here is actually create a relationship between the center of the point of the circle and this vertical. So if I wanted this to line up, so right now it's lined up, but it's not locked in place. Oh, actually it did create a... Okay, I'm learning something new in CATIA. It auto-created the constraint. Actually, SOLIDWORKS does this. I was not aware that CATIA was I guess it's the newer CATIA. So when I moved it over and lined it up, it automatically generated a constraint, as you can see. Let me delete the constraint just to show you how to do it manually. So once again, just by hovering towards it, and see how you have that light blue line letting us know it's lining up with the vertical. It automatically generated this ring, this constraint. So now it's locked. As you can see, I can only move it up and down, but I cannot move it horizontally because it's locked to that line. So that's a coincidence constraint. Let me go ahead and delete it and show you how to do it manually. Let's say it did not generate the constraint, or you wanted to do it manually the long way. Notice now it's free to move. Okay, so if I wanted to create a relationship between the vertical and the center point, I'm going to hold down to the control key on the keyboard, select the vertical, select the center of the circle. It's hard to see that center point. Notice how it lights up here on the tree. So now I can let go of the control key and say, hey, I want a relationship between that point. I want you to notice that it lit up because it noticed that you selected an element or elements and it lit up, allowing you to create a relationship constraint. So I'm going to say, hey, I want this to be coincident, or say, hey, I want the center to be at the midpoint of the line. So we can pick a midpoint relationship, as you can see, take it to the midpoint. I'm going to turn that off. I'm just going to say, hey, I want it to be coincident to the line, but not the midpoint, unless you want to. And I'm going to hit OK. And notice we have that constraint, and I can take this circle. Notice I'm missing a diameter or a radius constraint. Also, I can grab the point and I can slide it up and down, but not left and right, left or right. So just to show you that we do have, I'm just clicking in space to deselect. There's our constraint. Center lines up with the vertical. All right, so now we need a diameter or radius. So I'm going to add a dimensional constraint. And I need to click a second time to position it. There it is, positioned. Double click. And I have the option to give it a radius instead of a diameter. If it's a full circle, go with diameter. If it's an arc, a partial circle, go with radius. Okay, so I'm just going to type in a diameter. I'm going to say 10 and OK. There it is. Okay, now notice it's free to move vertically. So I can put a dimension if I want. Dimension from the base to the center. And now we need a third click to position it, to position our dimension. Also, you can also right click to position the location of that dimension and click. Yes, so you can right click and it gives you more options. Okay, when you're in the middle of creating a constraint, you can always right click for more options. I accidentally turned my sketch. I can always hit normal here to straighten it out. There it is. So I accidentally rotated by mistake. Let's talk about rotate. Okay, let's go back to, I think it's the third slide. To rotate, you hold the wheel and you hold the right button at the same time, and then move the mouse to rotate. Okay, so if I hold the wheel, hold the right button, notice I rotate. Typically, you don't want to rotate in a sketch. You want it to be parallel to the screen. But if you accidentally rotate, you can always hit normal. Another way of rotating is by grabbing the top of the compass, also referred to as the robot. You can grab the top point to rotate. Let's hit normal again. If you hit it again, it'll rotate at 180. There it is. All right, so we have green sketches. That's good. If it's green, we cannot move it. We cannot lengthen it, etc. Let me do a zoom fit. Okay, so let's keep, we're going to stay in Sketch because I want to go over a few things in Sketcher that are very important. And I'm going to make a separate video for some of these commands. So we'll come back to a lot of these commands in a separate video. Okay, so as I mentioned, you want your sketch to be green. If it's green, everything's been defined. It's locked in place, the length, the location with respect to the axis. Notice how this circle is green. So this circle, we know its location with respect to the origin. So we have these dimensions to lock the location of the center. And there's also, it's hard to see, but somewhere back here is a diameter. So the size of the hole, the location is locked in place. It's green. If it's white, it's telling us it's missing dimensions, right? So this circle doesn't have a diameter. This one doesn't have a diameter. That's why it's white. So if you were to pull on the circles, it'll increase the size, the radius or diameter. Or it may be that the location of the center hasn't been defined with respect to the axis or with respect to another element where you can add dimensional constraints. Okay, so if it's white, it's missing constraints. If it's purple, it's over constrained. It's telling us there's too many constraints or dimensions. Okay, so purple or magenta here means it's way over constraint. You need to fix it. You need to delete a constraint or two or more to get rid of the magenta. So I'm going to duplicate that. All right, so let me zoom in a little bit. So let me give you an example of what happens when you throw too many dimensions in. Let me change this to, I'm going to pick some nice round numbers. I'm going to change this to 20. Change this one to 10, just so it's more centered. And I'm going to change this one to 60. All right. I'm going to throw in a dimension here. Now, if this is 60 in height, this is 60, and this is 20, obviously, this dimension from here to here is 40. It's just 60 minus 20. Okay, so if I create a dimensional constraint, let me click in space to deselect. Click on the dimensional constraint, pick this line. I want you to notice that it's 40, right? 60 minus 20 is 40. So why did it turn magenta? Why is it purple? It's because it's over-defined. We have too many constraints. So what's happening is, if we look here on the tree, notice our new length, the 40, there's this yellow swirl. It's hard to see, but there's a yellow swirl here, letting us know it's fighting the other constraints. Why is it fighting the other constraints? It's because we don't need the 40. We know it's 40. We know this line is 40 simply by going 60 minus 20 is 40. So we're over dimensioning. We don't need this 40. This 40 can be calculated again by taking 60, subtract 20, it's 40. So there's no need for it. So these three dimensions are fighting each other. So in this case, we have to get rid of the least important one. All three cannot exist. Okay, so if I was to take this 40 and just simply delete it, I can right click delete or use the delete button on the keyboard. So now we're good. It's no longer magenta or purple. But let's say you wanted that 40 as a reference. Like, well, I want to keep that 40 just because I need to know this dimension. Is for some reason it's semi-important, not as important as the other two, but I want to keep it. All right, so if we go back and add the dimension, you can change it to a reference dimension, reference only. So if I double click and I say, hey, I want to keep this dimension, but I don't want to drive any geometry. I don't want it to fight other constraints. We can turn it into a reference constraint. Notice it places the reference dimension in parentheses. places the 40 in parentheses, letting us know it's a reference. And we can hit OK. So we know this is 40. If I was to increase this 60 to, let's say, 70, and hit OK, notice this turns to 50. It just took 70 minus 20, 50. Okay, so this is a reference only in parentheses. If I was to remove the reference, it'll turn back to magenta, which we don't like. So we either have to put it as a reference dimension with parentheses, right? Click and space to deselect. Or we can delete it. So those are the two options to avoid having a magenta sketch. Okay, so anytime you have a sketch turn magenta or purple on you, start at the bottom, look for yellow swirls, and start deleting the constraint. And then you may need to add new constraints to get rid of white geometry, right? Anytime a piece of geometry is white, like again, if we don't have a diameter, I'm going to delete this diameter. If it's white, it means it hasn't been defined, right? So in this case, we can add a diameter. I'll just make it 10. Okay, so over constraint, it's not good. It will not let you create a solid from this. Once you exit sketch and create a pad or extrude. All right, so let's go back to the lecture notes. So once again, purple or magenta is over constraint. You have to go into the CATIA tree and start at the bottom and look for yellow swirls and delete the yellow swirls first. Work your way up. If at any time you find yourself going in circles as you're creating a sketch, you're just going in circles. It's been 20 minutes, 30 minutes, and you can't figure out what you're doing wrong. Take my advice, start from scratch. Start all over again. Delete the sketch, exit the sketch, start a new sketch, and start all over again. Second time around, you'll create the sketch a lot faster. So again, if you're going in circles, start over. All right, let's move on. Okay, so once you're done creating your sketch, you want to do an analysis. Go to Tools, Sketch Analysis, and it'll run diagnostics to make sure, just to check to see if there's anything wrong. Okay, so let's go and do a sketch analysis. So go to Tools, Sketch Analysis. And it recognizes that there are two profiles. We have the circle. Notice we have the circle. And we have this profile, right? We have this profile made up of 6 curves. Yeah, lines are included as curves. So there's 6 curves creating this profile, and we want to see closed. We want our profiles to be closed, or else we're going to have issues creating a sketch. So everything's good. Let's close it. Now let me give you an example of a mistake. So I'm going to create, let's say I create a pocket here, or a cutout, a rectangular cutout. So I'm going to create, notice how it's trying to constrain itself. One thing you can do is zoom in to avoid your new geometry constraining itself to something else. So I'm going to intentionally leave a break there. Okay, I'm going to go ahead and exit the profile command. So sometimes it's hard to see, but sometimes you'll have a gap as shown. I can pull on the endpoints, or you're going to have the lines crossing each other. Okay, so I'm going to intentionally create this mistake. Sometimes it's hard to see when you're zoomed out. All right, so if I do a tool sketch analysis, Tools, Sketch Analysis, I want you to notice this is a third profile. So we have the circle, we have the outside profile, and then we have the rectangular profile. Notice it's open. It tells us it's open. And it's hard to see, but there's these little double circles, concentric circles. And the color is cyan, letting you know, hey, there's something wrong. So anytime there's something wrong, it says open, look for these cyan circles. Let me click away or click out in space to deselect. Notice the cyan circles, these double circles. That'll let us know you have a problem there, so you have to fix it. You either have to put a coincident between the endpoints or use the trim command. Okay, so whether they're overlapping or if there's a gap, it'll show you in cyan where the mistakes are at. Okay, so notice there it is. This profile is open. Let me close. Okay, so let me introduce you to trim extend. So trim extend. So it'll trim off any excess or extend to close the profile. So I want to extend this line up to this line. Notice it automatically closes it. Okay, so it's closed. So now if I go back to Tool, Sketch Analysis, notice everything's closed. That's what we want. We want closed profiles. We have 3 closed profiles. Okay, and close. Now there's going to be times where you create geometry that you weren't supposed to. And sometimes it's something small. It can be a line that you created or accidentally created and meant to delete and you forgot about it. So let me click out in space. So see this line? It's not meant to be part of the sketch. So if we go to Tool, Sketch Analysis, it'll recognize it. Hey, there's something wrong. See the cyan circles? You have this isolated line, or sometimes it can be a point floating in space that you don't need. And it'll prevent you from creating a pad, a solid from the sketch once you exit the Sketcher workbench. So you can click on the isolated. Notice it selects it. It's orange. And you can either delete it with the eraser. So this will delete it. Or you can turn it into a construction element. If I click construction element and turn it into dashed lines, which you can keep this line as a reference only. It's kind of like this reference, very similar. Or you can just simply delete it. Okay, so if I go back to this line, I can either delete it. Oh, I already turned it into a construction element, so I removed it off the list. I can just simply delete it if I want. Let me turn it back into a solid. I want to introduce you to construction versus solid lines. Click in space. Notice this is solid now. Sometimes you want to use geometry as construction elements. Think of it as scaffolding when putting up a building or a parking structure. When you're in construction, you're going to use temporary scaffold to help you reach or to walk above certain levels, right? Afterwards, you take it down, but think of it as construction elements or scaffolding. So once again, I can click on the element, turn it into construction, turn it into a solid if you want. So let's say it's a solid and we forgot this element exists. Let's go back to Tool, Sketch Analysis. So notice, hey, this is going to give you problems. It's an isolated element, so we can either turn it into construction or we can delete it. And close. Now, sometimes you'll forget and leave this option on, this construction option on, and you start creating geometry and you're like, oh, wait a minute, why is it dotted? Why is it dashed, I should say? Why are my elements dashed? It's because you had this option on. You can always turn it off, right? Okay, so you're going to constantly, oh, my mistake, didn't mean to turn that off. You're going to constantly be clicking and clicking this option off and on. Okay, be aware of it. Okay, I can go ahead and left mouse click and hold to window capture and delete. You're going to hit delete on the keyboard, and there it is. All right, so I actually don't need this rectangle, so I'm going to go ahead and left mouse click and hold. And I can right click and delete, or I can just use the delete button on the keyboard. Okay, so now I'm going to exit the sketch. Once you exit Sketcher, it'll take you back to the last workbench you were in, which is part design. Okay, so here's our sketch. We can always collapse the tree by clicking on the minus. We can always extend by clicking on the plus. So just think of it as a tree and branches and leaves extending, right? All right, I made a mistake. I want you to notice that this went dark. Okay, it happens to all of us. It'll happen to you. You will accidentally click on the white branches. See, it brings it back. Let me come back to this. But anytime you exit, your image goes dark. Click on the white branch again. Notice it's dark. It means I selected the branch on the tree. You can always also click on this white axis on the bottom right corner to exit that tree mode, which I'll explain in a minute. Okay, so let's go back and collapse the tree. Okay. I'm going to turn this into a solid or a pad. So if everything's good on our sketch, we should be able to create a pad. So we're going to create a pad. If you don't know what to do next, look here at the bottom left corner. So it's asking us to input information. Notice how this is blue. It's looking for a sketch. Okay, so we can select the sketch from here or directly in space, select the sketch. And it's already creating a solid. Notice it's creating pad number 1, and it took the sketch and tucked it under pad 1. This is to increase the thickness, right? If you want, or decrease. Or you can always type in a number. Let's say I want this to be 10 millimeters in thickness. And hit OK. So that's pad or extrude. Okay, and again, notice we are in part design. If you want to go back and change something on the sketch, you can always double click on the sketch to add more stuff. So if I wanted to add another circle, for example, and exit the sketch, it'll update and add the second circular hole, right? If I go back to sketch, add another circular hole, for example. Just for time, I'm not going to constrain it, make them green. Just for time, I'm going to leave it as white circles. I'm going to exit. And it updates the solid. All right, so let's practice zoom in and zoom out. So or pan first. If I hold the wheel, I can pan. I'm holding the wheel. If I tap the right button and hold onto the wheel, I can zoom in and out. If I hold both the wheel and the right button, now I can rotate. You can always rotate using this command here, right? You can always rotate, left mouse click and rotate. Just don't forget you also have the pan option here. Don't really need it. Left mouse click when we can use the wheel to pan. All right, so back to the tree. If you accidentally click on the branch, the white branch, notice the background goes dark. So you're in tree mode, meaning that now we can pan the tree. If I hold the wheel, now we're panning the tree, not the object. If I hold the wheel and tap the right button, now we're zooming into the tree. Sometimes you'll accidentally zoom all the way out and you start to panic. I lost my tree. It's okay. You can always do a zoom fit. There it is. And to exit the tree mode, you can always click on the white branch. Or you can click on the white axis here to go back into tree mode or exit tree mode. Okay, it happens to all of us. Another thing, the tree. If your tree disappears, most likely you hit the F3 key on the keyboard. So if I hit F3 on the keyboard, F3, that'll remove the tree. Sometimes you want to remove the tree because you want to take a screenshot and you don't want the tree to show up. If I hit F3 again, it'll bring back the tree. If I roll the wheel, you can move the tree up and down. So we're rolling the wheel. Okay. All right, let's go back to the lecture notes. So once again, if in a sketch you see cyan, that lets you know that we have a non-closed profile, or it's crossing, right? And we're not going to cover this. I may do a demonstration later on, but I probably will, using geometric sets. So a geometric set is to place non-solids. Think of your CATIA tree as a folder with dividers. The part body is for solids, or to create voids on a solid like a pocket or a hole. Geometric sets is for non-solids, planes, points, splines. For example, surfaces, so non-solids, you want to place them in a geometric set. And we use this quite a bit in the CAD 37 class. And it's a way to organize your geometry. To insert a geometric set into your CATIA tree, just go to Insert, Geometric Set. Okay, and you can insert as many as you want. To change your units, your grid size, you can always go to Tools, Options, hit the plus sign on the mechanical, go to Sketcher, and you can change your increments. The reason we have these funny numbers instead of nice whole numbers is because this is a metric software. It's actually a French software, and it defaults to millimeters. And we tend to change it in inches, right? Most of our assignments will be created either in inches or millimeters. Our first ones will be done in millimeters. To change our units. Okay, so we're going to be jumping between inches and millimeters. To change units, you go to Tools, Options, hit the plus sign on General, it'll expand the tree. Click on Parameters and Measure. Go to Units. Click the first one on the list, Length. Then if you go to the drop down, you'll be able to change it from inches to millimeters, kilometers, meters, feet, yards, etc. So let's go ahead and I'm going to walk you through that. So to change units, so our default is millimeters. So this is currently in millimeters. So to change units, go to Tools, Options, hit the plus on General. So this is a tree also. Hit the plus, extend the branch, go to Sketchers and Measure branch, go to the Units tab, go to Length, and currently it's in millimeters. So if your boss tells you, hey, change this to inches, I can go to Inches and hit OK. So now if I go back to my sketch, instead of millimeters, it's going to give me inches. So now all these are in inches. If I double click on it, you'll see it has the IN for inches. Let me cancel that. Double click. It has IN for inches, right? By the way, you can always override the units. So if I wanted to type in millimeters, I can say, hey, I want this to be 12 millimeters. I can type in mm for millimeters and OK. So it took the 12 millimeters and changed it over to it translated it to inches. Okay, double click. Hey, I want to make this 20 millimeters. 20 millimeters. And it'll translate it into or convert it into inches and hit OK. So 20 millimeters is equal to 0.787 inches. Alright, so we're going to be jumping between units, between inches and millimeters. And by the way, here also, if you want to change some of your units regarding mass, stress, like for stress analysis, density, etc., you do it here. Just select. There's a long list, by the way. Select the one you want to change, go to the drop down, and it'll give you options. Once again, always be aware of which workbench you are in. Later on, we'll be discussing assemblies. So this is a part in an assembly. If you're in assembly, you'll see the double gears. If you're in part design, you'll see the single gear. Notice when it's in single gear, it's telling us we are in the design workbench and the single part is highlighted. But if we're in assembly, notice the product, the assembly, is in blue. And then later on we'll be doing drafting. This is the drafting workbench. Okay, the last few weeks we'll spend it on drafting. All right, and just to quickly demonstrate assembly, let me exit the sketch. I'm going to open up one of your assignments that we'll do in a later chapter. U-join assembly. Okay, I want you to notice that assemblies are saved as .cat product files, extension files. Single parts are saved as .cat part for single parts, right? Assemblies, it's .cat product. That's the extension file. Okay, so I'm going to open up once again the U-join assembly.cat product. Open it up. Okay, so this is an assembly. It took me to the incorrect workbench. CATIA doesn't know. We can move this between different workbenches. By the way, there are over 100 workbenches in CATIA. So you can take this into a studio workbench, manufacturing workbench, 3D dimensioning, FTNA, functional tolerance and annotation workbench, or we can take this. Oh, let me exit. We can take this to the assembly design workbench. So watch how this icon is going to change to assembly. There it is. Now we are in the assembly workbench. Okay, so notice that the assembly is made up of all these parts. Notice the assembly is blue. We are in the assembly workbench. You see the double gear. If I wanted to change something on the part, maybe I wanted to add a hole on this part, I can double click on this part. I want you to notice it's going to turn blue for the single part, and it'll take us to the part design workbench. Double click. Notice now we are in part design. And now we can do part design. We can use part design workbench commands. So part design command, hole command. If I want to add a hole, notice it adds a hole to the part. Okay, if I wanted to go back to the assembly, double click on the assembly. Notice now we are in double gears. Now we have assembly commands listed. So in the assembly, I can add a coincidence constraint between a hole and a cylinder, for example, or a shaft. I can do an offset between parts to move them around. All right, so always be aware of which workbench you are in. If you can't find a command, where is the hole command? Where is the coincidence command? If you can't find a command, most likely you are in the wrong workbench. Okay, so always be aware of it, which workbench you are in. And other softwares that are out there besides CATIA. CATIA is one of the most powerful softwares out there, or probably the most powerful. And Pro-E, also known as Pro Engineering or Creo in Unigraphics, and CATIA are the top three most powerful softwares out there when it comes to CAD design. There's also SolidWorks, which we also have available in our computers on campus. SolidWorks is a step down, but SolidWorks is a lot more affordable and very common. SolidWorks is great for drones, small vehicles, but once you get into very large files like aircraft, like fighter jets or passenger planes or cars, then you want to use something more powerful like these three. And we also have Inventor on campus. Inventor is very common at the high school level. It's very affordable, very great for simple geometry, such as creating a design for robotics. Great 3D software. And then for 2D, we have AutoCAD. And for NC programming for machining, we have Mastercam on campus. And then there's also GD&T, which is not covered in this class. It's covered in a separate CATIA class, the CAD 33 class. I'm going to take a CAD 32 class on how to add dimensions in 3D. All right, so that's the end of the Chapter 3 lecture, and I will create a separate video to show you more Sketcher commands. End of lecture.